This tutorial will show you how to type your calculations for the percent yield of copper lead. The first thing that we need to do is include our balanced chemical reaction. So for the first one, we're going to write the balanced chemical reaction if iron 2+ is formed. There are two ways that we can get our subscripts. The first way, we can highlight the number, go to Format, Text, and change it to a subscript. To get out of the subscript, we can go back to Format, Text, and click on Subscript again. The other way that we can get a subscript is by using the shortcut. So the shortcut is going to be Control, comma. So I can press Control, comma, and my cursor is going to drop to a subscript. And again, I can press Control, comma to get me out of the subscript. In order to insert an arrow, I'm going to do -- greater than sign. As soon as I press the space bar, it's going to automatically change it to an arrow. So in this lab, we want to compare the moles of iron used to the moles of copper produced. So I can add an equation, and I want to go to Math Operations, A over B. If iron 2+ is produced, I can see that for every 1 mole of solid iron used, I can produce 1 mole of solid copper, making it a 1-to-1 mole ratio. Alright, I'm going to do the same thing now for my second reaction. I'm going to start with my balanced chemical reaction. And again, I can add my mole ratio by going to New Equation, Math Operations, A over B. If copper 3+ is produced, for every, let me make this a little bigger. Alright, if copper 3+ is produced, for every 2 moles of iron used, we would produce 3 moles of solid copper. So my mole ratio is 2/3. Alright, the next calculation that we need will be molar mass. When we are doing the calculation for molar mass, we want to show our work and we also want to include units. So the molar mass of copper is 63.55 grams per mole, plus sulfur, 32.07 grams per mole, plus 4 times the molar mass of oxygen, 16 grams per mole. And this is a hydrate, and I have 5 moles of water attached to my crystal. So I'm going to do 5 times the molar mass of water, giving me a total mass of 249.72 grams per mole. I also want to include the molar mass of iron and the molar mass of copper. Alright, the next calculation we need are the calculations for the moles of iron used and the moles of copper produced. So to do this, again, we're going to click on New Equation. And we started this lab with 0.50 grams of iron. And if we want to calculate moles, we are going to divide by the molar mass. So we can go again to math operations, A over B. And I can plug in the molar mass of iron, which is 55.85 grams per mole. Rounding to two significant figures, I get 0.0090 moles of iron. I'm going to do the same thing for the moles of copper produced. So going to my data table, my lab group produced 0.54 grams of copper. So I'll go back to new equation, 0.54 grams of copper. And again, if I am solving for moles, I need to divide by the molar mass. For every 1 mole of copper, there are 63.55 grams. Rounding to two significant figures, 0.0085 moles of copper. The next calculation that I'm going to do is the mole ratio of iron to copper. So again, I can go to new equation, A over B, and I'm going to look at the moles of iron compared to the moles of copper. So looking at our equations above, we used 0.0090 moles of iron and produced 0.0085 moles of copper, giving me approximately a 1-to-1 mole ratio. So I can now compare that to my answers up here, and that tells me that iron 2+ was produced. All right, the next calculation that we're going to do is our calculation for theoretical yield. All right, so first I'm going to start with iron. We use 0.50 grams of iron, and we want to solve for the theoretical yield of copper. So again, the first thing we need to do if we're starting with grams is divide by molar mass. Next, I'm starting with iron, but I'm solving for copper. So my next step is going to be the mole ratio. And since we figured out that iron 2+ was formed, this is the balanced equation that I'm going to use. It is a 1-to-1 mole ratio. And lastly, if we want theoretical yield, we want to multiply by molar mass to get to grams. All right, we have a second calculation for theoretical yield. We used 5 grams of copper 2 sulfate. So when we are in the equation function, we cannot go to text and subscript. It's not going to change it to a subscript. Control comma also will not work. So the way that we're going to get a subscript is going back to math operations, and we want to click on X with the subscript A. I can type my SO and then use the right arrow on your keyboard and it'll drop the cursor over to a subscript. If you arrow over one more time, you'll get out of that subscript function. I'm going to copy this so I can paste it the next time that I need it. All right, if we are starting with grams, my first step is to plug in the molar mass, which we calculated to 49.72 grams per mole. All right, I'm starting with copper 2 sulfate, but I'm starting with copper 2 sulfate, solving for copper. I have two different substances. If I have two different substances, I need a mole ratio. This is also going to be a 1-to-1 mole ratio. And lastly, if we are solving for grams, I need to multiply by my molar mass. All right, last up is going to be percent yield. So to get percent yield, I'm going to go back to new equation. And the first thing I want to do is type out the equation in words. So percent yield is equal to, we want to go to math operations, and the first thing we want to do is click on the parentheses. Once we have our parentheses, we're going to go back to math operations and A over B. The equation is we are going to take the actual yield divided by the theoretical yield and then multiply by 100. And again, I'm going to copy paste this equation. Second step is to plug in our data. So based on my data table, my lab group produced 0.54 grams of copper. So that is going to be my actual yield. The theoretical yield, based on my calculations above, is going to be 0.57 grams. Make sure at this step when we're plugging in values, we are also plugging in units. Lastly, we want to record our answer, 95% yield.